So let's introduce the custom op pack number 1. So if I go to my custom tab in op create dialog, you can see that I have the 5 operators that are in the custom op pack. So those include the flock sop, the fold dat, the QR reader dat, the schedule chop, and the timestamp dat. So I'm going to start off with the flock sop and explain how to get it up and running. So the flock sop, when placed, won't move at all until I give it a time step increase, which is basically this parameter here, and all I need to do is type in me.time.frame, and now it will update every frame. I can reset by hitting the reset button, and you can see that these voids start to move out from a point somewhere between 0 and 1. That's because the birth randomness is set to 1. If I set the birth randomness to 0 and hit reset, they all birth directly from 1. And that's more obvious if I turn off adaptive homing and reset. So if I have a birth randomness of 5 and hit reset, then they'll birth anywhere between 0 and 5 in X, Y, and Z. By default, they have a normal and also some custom attributes that points outwards from where they are facing. So it points the direction they are facing. So you can see here as they move, they are turning and steering towards, no goal right now because they don't have one. So we can choose the void's number, and in terms of performance, the void number and the perception radius are very important. So the void number, the higher we go, the slower the system will be. So as you can see there, it's quite slow at 1200. When you birth, it gets a little bit easier as you increase in time. So we have a birth position which chooses where they birth. So if I just come back down to about 300, the birth position, if I set that to 20, will birth them at 20 high. The birth velocity will give them an initial direction in which to face. So if I give them a really high Y velocity, you can see they start to head towards that direction. It's a directional velocity. The randomness I've already explained. So the perception radius is the vision radius of each void. So that's basically, if a void is within a certain distance, they'll start to affect each other, influence each other. So then the separation weight is how much they want to separate from each other. Then there's the alignment weight, is how much they want to basically go in the same direction. The cohesion weight is how much they want to be in the center of the swarm. And then there's the acceleration and velocity, which controls the steering speed and the speed of the actual void itself. The blind spot is just another parameter which you don't really need to worry about so much. It's not so influential, but it's there in case anyone really needs it. So I can turn on, if I just reset, if I turn on my target 0, we now have a target that's set to 0, 0, 0, and the voids will all want to flock to that target. If I move the target up, they start to head up towards it. If I move it down, they'll steer back down. When leaving these parameters quite static, it makes it quite static in terms of the look. So what I like to do is sometimes I like to just change the separation weight, and if you add a little bit of noise to that, then you can get a much more natural feel across the flock. Also, constantly moving your target can also help in various different axes. That can make it more fun for the voids to follow. There is a steering weight which decides how much the voids want to head towards the target. So if that's at 2, they're going to want to really get towards that target. But if it's at 0, they're not going to bother going for the target at all. So that is the flock sop in terms of its general pieces, parameters. One last thing to note is the perception radius. The higher the perception radius, the slower the system will run. So a low perception radius will give you better performance than a higher perception radius. Also, if you need them, there are some custom parameters. So if I go into the the SOP2DAT and I drag in, you can see here that we have the velocity and the acceleration are brought in from the FluxOp, or at least the velocity is. So that's the FluxOp. It's fairly straightforward. Next up is the fold DAT. The fold DAT takes a table input, and what it does is it folds the entire table into one single row or one single column. So if I call this A1, B1, C1, A2, B2, C2, so now you can see that I have A1, B1, C1, A2, B2, C2. So it basically just folds down all those parameters into one long row, a single column, or a single row, and it can also fold columns rather than the rows. So it has 4 different methods for folding down. The QR reader DAT is quite straightforward as well. It has a source top, and it tells you when it's reading data, and then it tells you what the data is. So I'm going to give myself a source. I'm going to make this my webcam. So here I am. So the video device in currently is set to 1920 1080. So I can just drag that on, but you'll see that things are quite slow, 43 milliseconds. So it's better to fit down to a lower resolution before using this DAT. The DAT runs on the CPU, so it's still not quite as performant as it could be. So that now runs at 6 milliseconds to give an idea of performance. And if I hold up a QR code to the screen, you'll see it starts reading the data, and the data comes in as Wikipedia. So if you watch the data, reading data will go to 1 when it's reading the QR code. So that's the QR reader DAT. There's then a schedule chop, and the schedule chop will allow you to turn the chop on at a particular time and turn the chop off at a particular time. And it can also be set to only work on certain days. So if you want to run a projector from Sunday to Thursday, you could turn off Friday and Saturday, and you could say, I want my projector to start at 9 AM, and I want my projector to turn off at 10 PM. And because right now we are at 7:22 PM on a Thursday, that schedule will work. If we said we don't want to run on a Thursday, then we can turn Thursday off, and now it will not set to 1 on Thursday, only on Sunday, Monday, Tuesday and Wednesday. So the schedule chop is fairly straightforward. You can have multiples of them, so if you have lots of different things you want to schedule, you can use it multiple times, as it's fairly lightweight. 0.02 milliseconds is quite cheap. So the last one is the timestamp DAT. The timestamp DAT is quite simple. It makes a timestamp in a table in row 00, and it has a format parameter for changing the formatting of that timestamp. The formatting is done via the C++ SGRF time reference, which is here. So if you go to this website, then you can actually just copy these different specifiers, and you can see the examples there. And if you type those in, then you'll get those values. You can also type in plain text too, so I can type in hello world at the end, and it will add hello world to the end. So that's the 5 different operators that are currently in the OpPack, and have a play around. And if you have any questions, then you can comment here or message via the contact form on touchdesignerplugins.com. So thanks a lot.